Black holes. Just hearing the term evokes visions of endless darkness, profound secrets, and forces beyond comprehension lurking in the cosmic depths. They are the universe's ultimate predators, mysterious entities that consume all, even light, leaving behind only a haunting absence in the tapestry of existence. Yet black holes are more than destroyers. They are the spectacular end of massive stars and the unseen anchors that hold galaxies together, sculpting the universe on a colossal scale. These cosmic phenomena stretch the limits of physics, compressing matter into a point where our understanding collapses and time itself seems to freeze. Our obsession with black holes is really a fascination with the ultimate unknown, where the boundaries of reality blur and mysteries multiply. What would it be like to cross that threshold? Where does everything end up? Do the rules of physics endure, or is there something more? These questions spark our imagination, driving an endless pursuit for answers. The event horizon marks the ultimate boundary, a cosmic gate from which nothing returns, not even information. For researchers, black holes are the most tantalizing and formidable riddles, constantly pushing the frontiers of what we know. Though invisible, we sense their presence through the chaos they unleash. Stars flung around unseen centers, gas igniting as it falls inward, and space itself bending to their will. We become cosmic sleuths, gathering evidence from the universe's most elusive phenomena, employing every instrument we have. Each breakthrough adds a new piece to the puzzle, challenging Einstein's ideas in the most extreme environments and unveiling fresh enigmas. Black holes reveal the cycles of stellar life and death, the origins of galaxies, and the very structure of the universe. Strangely, these voids of darkness illuminate some of the universe's deepest secrets, casting light on what we do not yet understand. They challenge and inspire us, reminding us that knowledge is never complete and that the cosmos is far more bizarre than we can imagine. Black holes are the universe's ultimate illusionists, concealing truths behind warped space-time, daring us to unveil their mysteries. And with every new discovery, we inch closer to unraveling the secrets of our universe, one enigma at a time. Every great discovery starts with a whisper from the cosmos, a subtle hint that something extraordinary is waiting to be found. For Christian Wolf's team at the Australian National University, that whisper was hidden deep within the vast data collected by the Gaia spacecraft, a mission designed to map the stars with unprecedented precision. The team wasn't searching for records or fame, just for interesting, unusual objects in the universe, when they stumbled upon something truly remarkable. They noticed an object so intensely bright that automated systems initially mistook it for a nearby star, blending it in with countless others. But when they examined its light signature, it was clear that something didn't add up. The data was unlike anything they had seen before. It turned out to be a quasar, an incredibly luminous, distant beacon powered by a supermassive black hole devouring matter at a furious rate. Catalogued as J05294351, this object shone with the combined light of over 500 trillion suns, outshining entire galaxies. The data was so extreme, so outside the norm, that it was almost dismissed as a technical error. But the team's curiosity and intuition pushed them to dig deeper. They decided to take a closer look using the powerful Very Large Telescope in Chile, seeking confirmation of their incredible find. The detailed spectrum revealed the truth. This was no ordinary star, but a quasar from the early universe, shining across cosmic time. Its light had travelled for over 12 billion years to reach Earth, offering us a rare glimpse into the universe's distant, formative years, almost like seeing the cosmos as a toddler. Discovering such a luminous quasar from that ancient era was like finding a towering redwood in a forest of saplings, an extraordinary outlier among the faint galaxies. The discovery raised a profound question. What kind of cosmic engine could possibly power such overwhelming brilliance and energy? The answer was astonishing. An unimaginably massive, ravenous black hole, consuming matter at a rate never seen before, lighting up the universe from across time and space. Measuring a black hole 12 billion light-years away is no easy feat. Gaia flagged J05294351, but the real work began with the Very Large Telescope's powerful spectrograph. By splitting the light, astronomers identified the elements swirling around the black hole and measured its redshift, confirming its vast distance. The next challenge, estimating the black hole's mass. The quasar's brightness hinted it was feeding at the Eddington limit, the maximum rate before radiation blows away incoming gas. By calculating its luminosity, scientists worked backward to estimate the black hole's minimum mass. The result was staggering. A cosmic giant revealed through elegant astrophysical detective work. It was a triumph of combining data and physics to uncover the universe's secrets. How big is the black hole in J05294351? 17 billion times the mass of our Sun. Its event horizon would swallow our entire solar system, stretching beyond Neptune's orbit. For comparison, the Milky Way's central black hole is just 4 million solar masses. This one is over 4,000 times bigger. Even the previous record holders pale in comparison. What sets it apart isn't just size, but appetite. It devours a sun's worth of mass every day. As matter spirals in, it forms a superheated accretion disk, glowing with unimaginable intensity. The disk itself spans 7 light-years, an enormous, swirling beacon. This black hole is the fastest growing ever observed, pushing the limits of what we thought possible. Its existence challenges our models of black hole growth in the early universe. How did it get so big so fast? J05294351 is a fundamental clue to the processes that shaped the cosmos. It's not just a curiosity, it's a game changer. The quasar powered by this black hole is the most luminous object ever detected in the universe, a true cosmic beacon that defies expectations. Its staggering brightness equals over 500 trillion suns, outshining every star in the night sky by an unimaginable margin, making it a cosmic lighthouse visible across billions of light-years. If it were located in our own galaxy, its light would be so intense that it would actually cast shadows on Earth, turning night into a surreal twilight. This extraordinary brilliance comes from the black hole's feeding frenzy. Matter spiraling inward, accelerated to nearly the speed of light, and heated to temperatures far hotter than any star we know. The black hole itself remains invisible, hidden by darkness, but its accretion disk acts as a cosmic spotlight, illuminating the surrounding universe. Here's the puzzle. There's a theoretical speed limit, known as the Eddington limit, that dictates how fast a black hole can grow by feeding on matter. Feed too quickly, and the intense radiation should blow away any incoming gas, effectively shutting down the black hole's growth. Yet J05294351 seems to be pushing, or even outright breaking, that limit, growing faster than theory says is possible. How does it sustain such a high rate of growth, defying what we thought we knew about black holes? Maybe accretion disks are far more complex than we imagined, clumpy, magnetized, turbulent, or perhaps governed by unknown physics. Or perhaps our understanding of the Eddington limit itself needs a major update as new discoveries challenge old assumptions. This quasar is now a natural laboratory for extreme physics, pushing our theories and models to the very edge of what's possible. It's where new science begins and where the mysteries of the universe invite us to look deeper. A 17 billion solar mass black hole, just 1.5 billion years after the Big Bang, challenges everything we thought we knew. Standard models say black holes grow slowly, merging and feeding over billions of years. J05294351 breaks that timeline. To reach its size, it would need a massive head start and constant maximum feeding, an unlikely scenario. This suggests rapid alternative formation pathways, like the direct collapse of massive gas clouds, skipping the star stage. Such seed black holes could grow much faster, explaining giants like J05294351. This discovery forces cosmologists to rethink early universe simulations and black hole growth. It opens a new chapter in our understanding of cosmic evolution. Black holes aren't just cosmic vacuum cleaners, they're galaxy architects. The energy from a quasar like J05294351 can heat and blow away star-forming gas, regulating galaxy growth. This feedback creates a cosmic dance between black holes and their host galaxies. The mass of a galaxy's bulge is tightly linked to its central black hole. Finding such a massive black hole early on suggests this relationship began at the dawn of time. Did the black hole form first or the galaxy? It's the ultimate cosmic chicken and egg question. J05294351 is a prime target for future telescopes to unravel this mystery. These giants weren't just destroyers, they helped build the universe we see today. The discovery of J05294351 reminds us the universe is stranger and more wondrous than we imagine. Every new observation challenges our assumptions and expands our horizons. Science thrives on these surprises. Each puzzle is an invitation to learn more. This distant quasar has already reshaped our understanding of black holes and galaxies. It inspires astronomers to search for more ultraluminous quasars using ever more powerful telescopes. Human curiosity drives us to ask why and what if, connecting us to the cosmos. We may never visit a black hole, but we can study and understand them from afar. So keep looking up. The universe is full of wonders waiting to be found. The greatest adventure is the endless pursuit of knowledge.